Welcome to Code Club. So if you don't know, the idea is we're going to read some Go code and talk about it. So let's take a look, because by popular demand, I'll look at some code involving generics in Go. Now, the idea is that what we're looking at here is not Go, just to be clear. So this is about a proposed extension to Go or an enhancement to Go, which is commonly referred to as generics. And that means a few different things to different people and different specific things. But in general, it means what you think it means. It means being able to deal with any kind of thing, regardless of what specific type it is. Now, if you've spent any time playing with Go, you'll know that Go has a very strict type system, which means, every value and variable and parameter has some specific type. And if you try to pass something that doesn't match, the compiler will be angry with you, and it will tell you very quickly that you're not allowed to do that. So the idea of generics is we might like to write some function which could take any type of value. So imagine, we might want to find the maximum value in some list of values. So we might write a function which loops over a slice and says, is it the biggest yet? Okay. Is it bigger than the biggest I've seen? Okay. That's the new biggest. And then it returns the biggest value. But the problem with writing a function like that is that we'd have to specify the type of its parameter, right? It would be a slice of int, let's say. So that's great, but now you want to get the max of a slice of float 64s. Well, you can't use that function. You've got to write the exact same function again, but this time one that takes a slice of float 64. And multiply that by all possible types, including your own struct types and so on, and it's going to get very annoying. Clearly, it would be nice to write a function which just takes some arbitrary type and then does some operations on that. So that's what this is about. So let's start by looking at this code. Someone on Twitter sent me this, and I'm sorry I've forgotten your name. But this is basically their attempt to play with generics. So there's a specific proposed way for doing this in Go, and they've made a version of the Go playground which supports it. So you can play with this right now. You can go to goplay.golang.org. And it's exactly like the regular playground, but you can use generics. So would somebody like to start us off by just kind of trying to read through this and see if we can figure out what's going on?
Sure, I'll start. Outside of the normal, we've got a package main. We import func package.
So far, so familiar, right?
Yeah.
Not too hard.
We have a user-created type called record t_any. I think this is a slice of any type.
Yeah.
Or
so this
implied to be a slice of any type.
Yeah. So we already departed from valid Go here, so this would not compile.
Right.
Normal Go because of the square brackets after the type name, right?
Right.
We're quite happy writing something like type record struct.
Yeah.
But the square brackets and something inside those is not familiar to us yet. So let's keep going.
And this user-defined type with the funny-looking code has an underlying type of a struct, which is standard for Go stuff, and one parameter or element data, which I'm assuming is a
one field
type. Right. Then we get to a function, which is a method that has a.
It looks complicated, doesn't it?
Yeah. A pointer to record with a slice of T. Interesting. Or an array of T. I don't know.
Let's keep going and see if we can figure that out.
which is called update method. Update method would point at a record. It takes an updater, which is a function on T,
Mhm.
and that r dot data equals updater r dot data. That okay? That's it's weird.
Yeah. Well, actually, that's not so weird, is it? Because suppose updater were a regular func that takes something,
Sure.
and it returns the same thing. So we're saying r.data is equal to calling that function on the current value of our data.
Right. Sure.
Here's some function which will modify your data, and that's what this method does, it looks like.
Guess I wouldn't write my functions like that.
Sure. There's no guarantee that this is great code. It's just code from the wild that's drifted in on the breeze. So we'll see if we can understand it. Anybody else like to have a go at func main? And feel free to jump in with questions, by the way. I mean, I'm sure there are many questions. So.
I have a question.
Okay.
Why is couldn't we handle this using Go's interface type?
Right.
Interface.
That's a really good question. Anybody like to try and answer it?
I mean, an interface type still requires you to have your elements be of a specific type, right? So like if you had a record that you created and it had an element called data, you would have to say that element is of type int or something.
Right.
Or it had some kind of underlying type. You could create a new type to kind of mask that away, but it had some kind of underlying concrete type.
I guess my thought though would be you wouldn't have to go outside of what Go knows in order for it to work.
Yeah, that's right.
It's relative to the language, so.
Yeah, so Mike's perfectly right that if you wanted to write some function that takes any type, of course we know about functions like that. Func.println, for example, will take anything. And so I suppose his question is, why would you not just do that? Why do you need this stuff?
I misunderstood. You mean the empty interface?
Yes.
Why couldn't you just do that? I was thinking of, like, couldn't you define a definition with the interface to do something similar to what's in this code?
Yeah. Well, actually, it's kind of the same answer, isn't it? That an interface is the mechanism we have in Go to say, I don't care what exact type it is, so long as it has a method, say, like an IO reader has a read method. Or in the case of the empty interface, I'm saying nothing at all about what methods it has or doesn't have. And the problem with that, as you said, Tom, is that you have, in order to do anything with it, you have to assert the concrete type that it is. In other words, if you had something which you know is a string, but you have it in the form of some interface, and you want to append to it, let's say, you've got to type assert it into string before you can do anything, and that could fail because it might not be a string, so you'd have to handle that. So basically, empty interface in your code is like a bomb that could go off at any time, and you have to constantly make sure it's not going to detonate on you. So it's a bit inconvenient. But I think it's fair to say that some people, that their answer to this would be, well, we don't need generics. We can do everything we want to do with Go as it is, so please don't mess with our favorite language. And I have some sympathy for that point of view. But the Go team regularly surveys people about what they like and don't like about Go and what they would like to see in Go, and generics seems to be the top thing that people not currently using Go are saying, the reason I'm not using it is because it doesn't have these kind of facilities. So they're proposing adding some facility like this. And the point of it is basically that it would answer your question, Mike, that it would be an easy way to pass generic values around, have a function that takes any type of thing. And the proposal is that that would be more convenient. So let's see how that actually works. So would someone like to have a go at func main?
Sure, I can give it a shot. So in func main, we're assigning a value to our variable r of,
Yep.
and the way I read this is a record of type string that has in it, you know, a value, a data value of type string, because the type and the type of the struct should match the type of the, or T should be the same, right?
Yeah, that's right. I think what we're saying here is type record of any type T is a struct which has a field called data, which is of type T. So as you said, a record of string would have a data field which is a string. So we're creating that with a literal there.
We're then essentially taking and printing out the value of the data element of the record that we just created.
Yeah, Tiago, did you want to ask something?
Yeah, so sorry, I'm newbie in Go, so maybe it's a stupid question.
That's very welcome. We're all newbies to some extent.
You are not specifying the type at the end of the day. Like you must specify that's a string when you are setting the record. So for me, like, what's the difference when you need to like use this new type and the usual value, a usual type like string or int?
Yeah, I think I get your point. So are you asking, saying this generics is all very well, but when you use it, you actually have to specify the type anyway.
Yeah.
So what's the point?
Goes back to my initial question about interfaces.
Yeah, that's fair. But let's assume we accept the desire for generics. And so, well, the problem is basically that we'd like to write functions which take a parameter of some arbitrary type. Notice, not a value of an unspecified type, that would be empty interface. But they take, you know, a value which is some specific type, like string, but we're just not going to say in advance what it is. And the $10 word for this is parametric polymorphism. So, in other words, our parameters can be polymorphic. That is, they can take any type. So, as you said, Tiago, when we actually use this generic record type, we have to say it's a record of string, or perhaps the compiler can infer that we want a record of string. But the nice thing is when we write this method, we don't have to say anything about string. So we're just saying, so the type definition says for any type T, please make me a struct with a field of type T. And then the update method says for any pointer to a record of T, here's a function which takes a function. So what you pass into it is a function which takes a T and returns a T, right? So in the specific case that we're thinking about, you need to pass a function which takes a string and returns a string.
Got it.
And then it calls that function, whatever it is, on R. But at no point did we ever have to say anything like, if it's a string, do this. If it's an int, do that. If it's a struct, do something else. See what I mean?
Got it.
So, yeah. Keep going, Tom, or did someone want to take over?
Well, I think you just described the next line essentially, which is we are creating a function, an updater function for our update method. So an anonymous function that takes in a string and returns a string. In this case, it's just going to take in, it's going to add to its parameter the word world, or the string world.
Yeah. Okay. I think things are starting to become slightly clearer, aren't they?
And then, of course, we're going to print out what happens after we call our update function.
Fine.
So,
okay. So this is actually one block where we're kind of using a generic record type. So we create a record whose value is hello, and then we call update on it, passing it a function which adds world onto the end of whatever it is. So afterwards, it should be hello world, shouldn't it? So let's just try it. Yes, so this is the first bit. So before is hello, after is hello world. Okay. Who would like to ask a question about that before we get on to the second bit, which is just the same thing but with int? If you're feeling very confused, don't feel bad. I'm sure everybody watching this is feeling a bit the same. Can you zero in on anything specific that's confusing you?
Well, you're returning current value plus world, but it's not assigned to a variable. It's just a function parameter. But I guess that's fine. Yeah.
Yeah, would it help if we pulled this out and gave it a name? So let's say, call it something like append world. Takes a string and returns current value plus world. And then suppose we pass that to our update. Yeah, that works. So does that make this clearer? Or worse? Better or worse?
No, because update takes a function and we use that function to
it's just sometimes looking at functions that take function literals causes brain overload. Too many funcs within funcs. But,
that's how I would have written this particular example,
yeah.
Just to be very explicit and clear what's going on. But
yeah, and this isn't a generics thing, is it? We're kind of used to seeing functions in Go that occasionally take functions.
right.
Can't think of a cogent example right now, but there are many. Sort slice is one, for example. So if you want to sort a slice, you can call sort.slice from the standard library, and you pass it a function which does this, which compares two elements. Right. So for any arbitrary struct type, you could sort a slice of them by providing a function which compares the two structs and tells you which one should sort first. You know, if you want to sort a bunch of people structs by name, you could sort them on the person's surname, for example. So we could do this without generics if record was just defined as a struct type that has a string field, right? So the only fancy bit we've actually done here is we've just used this generic record type. And we also have a generic method because it's a method on a record of t, whatever, for some t, right? It takes a function which takes that t, whatever it is, so that must be the same here as it is here, and it returns that same type. So for a record of int, we would need to pass a function that takes int and returns int. So I think that's what we do here.
Right.
So anyone like to walk us through this?
It's the same as the above, just using a different type.
Pretty much, yeah. And
I see this being used in video game development.
So in this version, we've got an int record, which is just 1, and we pass it an updater function which returns current value times 2. So we should see before 1, after 2, and that's what we do see. So Questions on that would be most welcome. So it's very difficult to ask for questions, because if you sort of say, any questions on that? It's like, is anybody that dumb that they don't understand this? If so, please out yourself in front of the group. It's difficult to find a way that actually invites questions, because that's basically why we're here, is to do Q&A. If everybody's just like, yeah, I'm cool with that, we can all log off. So let's ask some questions.
Yeah, I think for me, is my background is sysadmin, so like I'm not experienced developer. It's hard for me to imagine a case where it would be very useful, because we still have to create the functions to handle the string, another function to handle the int. So I'm not really seeing what's the value that it would bring to, but I'm sure there is a value. I'm just not able to see it.
Yeah, well, don't worry. I'm sure there's plenty of experienced developers looking at this thinking, A, I don't understand it, and B, I don't want it. Like, why would I want this? I've got another example here, which is a bit simpler. So I have a tutorial on my site, which you might have seen. So I've got a few little Go tutorials about specific things, maps and empty interface and other things. And I thought what it might be interesting to do to help me understand this stuff is to try and write the tutorial for generics as though they exist. In other words, as though they've already been merged into Go, and to just explain to people how to use them. So what I've said is, I've said, the first thing we might like to do is to write a function which prints whatever you send to it. Let's call it print anything. And here's an example of using that. So we have this function print of t any. So any just means literally any type. And it takes a slice of t, no problem there. And it just ranges over the slice, printing out each element. So I think that's reasonably clear, isn't it? Apart from the t any stuff, I mean, if you saw this function for any specific type, it's reasonably straightforward. And here's where we call it. We'd pass it a slice of string, hello playground. So does this work? I have no idea. Yes, it does. Good. Would anybody like to try and recap what's going on here? It's a slightly simpler version of what we've been following.
Oh, I'll give it a go.
Good man.
Like we have a print function that takes parameter of t, which is implied of any type.
Yeah, I don't exactly know how to say that. Like we would normally say a function print takes so-and-so, returns so-and-so. I don't really know how to describe a generic function, but I might say it's a function of t any, which takes a slice of t, etc. No, you say it how you like.
Yeah. We'll go with that. It's a function of t any or any type that returns a slice of that type that's passed to it.
Takes a slice of whatever t is, right?
Yes.
It doesn't return anything.
I'm sorry. I'm looking at this the wrong way. This is
I know what you mean. So it looks like these are the parameters to the function, and this is what it returns. So if it returns something, it would be like,
right.
You have 3 groups of brackets. So the original syntax they proposed for generics was to make these regular parentheses. Now we're into something very confusing, and a lot of people were really upset by that. Some people wanted it to be like this.
All right.
I
It's
think
the
that's
square brackets that denote that this is not a function parameter.
right. So I think this is how it is in Java and C++, for example. They might correct me if they know better. But people didn't like that, and they didn't like the round brackets. And so we're using square brackets, which is potentially a bit confusing because it kind of looks like a slice, but it's not.
Do you know if in the spec they're planning to do any inference, like essentially infer that if I've passed in a generic, what is a generic type, or what they assume is a generic type, or if they can tell at that point, that you wouldn't have to provide the square brackets?
Yeah, well, I think that's. Do you mean when you call it?
No, I mean when you define the function.
When you define it, so saying perhaps just omit these.
Yeah, because I've passed in, again, T could be, I haven't defined T anywhere else, and it could be defined as somewhere else,
Yeah.
presumably. So I guess I don't know if it's intended to work or not. If T is intended to be sacred in this scenario, I presume not. But
Yeah, no, there's nothing magic about T. So let's call it X.
yeah.
Now I'll get rid of that. If that's deliberately making things worse, this isn't quite so bad. So yeah, so you're saying if you omitted these square brackets, you could say perhaps there's some, if X is not the name of any defined type, in fact, then Go would just say, that must be some type that I don't know about. So now I'm going to allow you to use X, because maybe
Well, that becomes a function that takes a slice of X.
It did before as well. It just was X was of type any. And now
Right,
we don't
but I
necessarily
think,
know what type
doesn't
X
Go
is.
now get confused whether am I a function? I see, you're saying the internals should define whether or not you're using generics or a regular function.
Yeah.
Yeah, my question was like, will it do any kind of type inference based on what it knows? It seems like the answer should be no, given the fact that there could be so many weird things that could happen if you, for example, if it was just always going to infer that a type that's not defined in a function is of type any. That could cause all kinds of issues when you were, in the process of writing code.
Yeah,
I would think.
I think with something like this, given that they're having to bolt it onto an existing language and try not to break any existing code, and also to provide something that's going to work with everything else people are doing in Go, that's inevitably, there's never going to be a perfect way to do this, is there? It's just, they're like, we deliberately didn't give you generics because we couldn't think of a good way to do it, but you insist on having it, so we're going to do it the best way we can, and if you don't like it, that's on you, buddy. I think you're right, maybe inferring it would have been easier, but they've chosen to make it very explicit. So they've just said, here is a generic function of some type X. And so if you didn't need to refer to it at all, you could do something like this. You could say, suppose you had this, you're saying it's a function of some type T, which in fact takes a string and prints it out. So I think that would work. It's just a bit pointless because since we don't need T, it doesn't need to have a name, and because we're providing a concrete type here, we don't need it to be generic at all. So, so this is a bit silly anyway, because as we know, func print prints anything anyhow, so you really don't need this. So my next example is, suppose you want to do something where you can't just call func print on it. Suppose you wanted to, we have a strings join function in the standard library, takes a slice of string and returns one string. Supposing we wanted to write the generic join function, takes a slice of T and returns a string of jamming them all together. We might try and write something like this. first go. Seems reasonable. Like, so we understand this syntax now. Join, it takes any type T and it accepts a slice of T as a parameter and returns a string. And we range over the slice each time appending, we turn the element into a string and append it to our result. And
that assuming that you could, that you can type assert that the underlying type to a string.
Yeah, you're way ahead of me. So that's so this doesn't work. The reason being, how do you know that V has a string method? It might not. And Go is not into YOLOing stuff at runtime, and if it doesn't work, crash. That's not how we do. So the compiler wants to assure itself beforehand that this is going to be successful. So what it's really saying is you can't just pass any type. You need to basically, if you're going to call string on things, you need to only pass things which have a string method. That's clear, isn't it?
I could see a lot of panics happening.
Yeah. So that wouldn't be good. So can you, off the top of your head, think of a way of specifying in a function that whatever it takes as a parameter must have a string method?
The name of it?
But beyond that, what hint can we give the compiler that whatever this value is, it's going to have a string method? Sounds like interface would be the thing for that, right?
Ah, my favorite.
Yeah, everybody loves interfaces. So, you know, if you want to write a function in Go right now, today, without generics that accepts stringable things, you know, you can write an interface, I'll call it Typestringer. An interface is just a method set. So we just say any stringer must have a method called string, which takes nothing and returns a string. And it turns out we can actually use this interface name instead of any. So where we previously said join T any, we might say join T stringer. Now that's a little better, isn't it? Because the compiler can say, yep, I know that any V will have a string method, so I'm fine with that.
I guess I'm not seeing where I would need this generic method any longer if I have this.
Right. Yeah, you could perfectly well write a method that takes a slice of stringer, right?
Right.
And you can. That's fine. You can accept your stringer interface value, and you can call string on it. You're absolutely right, Mike. And if this were all there was, it'd be a pretty weak case for generics. But the next thing I look at is, suppose there's something you want to do with these parameters which you can't describe as a constraint by method set. So here, for example, you know, instead of saying T any, we're constraining it by saying only stringers, only things that have a string method. But suppose we wanted to do something which isn't about calling a method. So the example here is, suppose you want to write an equal function which takes two things of type T and tells you whether they're equal. That's a bit trickier, isn't it? Because the compiler won't accept that, because it says, given two values of some unknown type, I have no way of knowing whether I can use the equals equals operator.
Right.
Yes, Tiago.
But why can't you use reflect in this case?
Very good question. Well, my answer would be reflection is a huge pain. It's just really awkward. Basically, anytime you're importing the reflect library, you're probably doing something wrong. Well, there's probably an easier way to do what you need to do, because firstly, reflection is very slow, because the only way it can work is to try every possible type and say, is it this? Is it that? Is it an integer? Is it a float? Is it a string? And okay, they've done that in the standard library, so you don't have to write it, but it's still really awkward. And it still doesn't really help you, does it? Because we'd have to say something like, if reflect.type is string, then return a equals b, or if it's int, then return a equals b, or if it's float 64, then return a equals b. Clearly, there's something not so great about that.
Right.
Well, so what we would like to do is we would like to say, you know, instead of any, some constraint on type T, specifically that it supports the equals operator, which is the technical term for this is it's comparable. In other words, you know, you can say 1 equals 2. It's a really simple constraint, and we would just like a way to express this, just to say this, whatever this type is, it's comparable, right? And there are lots of types that are comparable, like ints, floats, strings, and so on. And the idea is they're going to provide a keyword for this comparable, so that we can just write literally that. Now, this may not be the final answer, but it's the way they're proposing doing it right now. So we would say, let's actually do this. So let's have a go in the playground. So let's write, we'll try it with any, we know that doesn't work. So let's just call equal 1, 2, let's say. Does that work? Nope. But it's not my fault. It actually says, yeah, don't know enough about T to be able to call equals on it. So now suppose we say T comparable. Does that work? Yes, it does. And they're not equal. So let's just see what happens if they are. Hopefully this works too. Yeah, it does. So,
what happens? Sorry. Will it throw a compiler error then if I provide 2 types that aren't comparable, like,
great question.
I don't know, the slice of dates or something?
Yeah. Excellent point. Yeah, let's do that. And let's say, you know, A equals a slice of int 1, 2, and B is the slice of int 1, 2. These are equal, we can see intuitively, but will this work? Nope. And we kind of knew it wasn't going to, didn't we?
So the short answer is we kind of still need something like reflect or some other library that does like a deep equal.
Well, yeah, I mean, that's a good point. If we have this generic function equal, we can call it, but we have to call it with some specific thing, and it has to be comparable. So we'll have to make sure, either because we know what type it is because we constructed it, or if someone's passing. So what you're really asking is, what if we had a generic function that takes some values of T and then calls equals on them? How do we know that it's comparable? So
yeah, essentially, yes. Yeah.
Let's try and write that. So let's say compare for T any takes A and B and returns bool. So we can just do something silly like if equal AB, return true, else return false. Now, clearly, I think we can all see this is equivalent to just return equal AB. But just for fun, let's write it out the long way. So what you're saying, Tom, is that this wouldn't work. No, I think you're right. That's probably my fault.
You're missing the type in your parameters.
Right, thank you. Yeah. So we're saying those are T. Right. So at line 12, T does not satisfy comparable. So yeah, so I have a completely generic function that takes literally any T, and then I try and call some function which is constrained to only comparable types. Just as you might expect, the compiler says, nope, no, you can't do that because I need them to be comparable. So we might say, we would have to make this comparable, right? Or we could say something like, we would like a way to do something like a type assertion. There's no way to write that I know of. The way.
What I guess I was more kind of getting at, I think, was mainly the fact that having this comparable keyword, basically saying, "Hey, a type is comparable,"
yeah,
it's nice because it constrains what comes in, but it's not, and maybe it's not intended to, right? But it's not addressing the need for something like the reflect package or the goes cop package to compare, like to deeply compare something.
Yeah, so I suppose we can say it's not, you wouldn't be justified in saying until Go gets generics, you just can't do this type of thing, because you definitely can. If you use interfaces and reflection and so on and so forth, you can basically do that. However, it can be mighty inconvenient. It's maybe not something that comes up a lot. I mean, I suspect most of us here are thinking, well, I never actually have the need to write programs like this. So what's the whole thing about? And I sympathize with that. I very rarely do either. But some people, let's say, for example, I want to write a generic list manipulation library. Given a slice of any type, I want to be able to get the max, get them in, map a function across it, reduce it by combining all the elements in some way. And I can't do that. So what's up with that, Go? And I'm like, well, we just don't write those kind of libraries in Go, or not too much. The reason being, when we're writing some specific program, we have some specific type in mind. So we just write our function on that. We don't write a generic equal function. We write it for some specific.
Doesn't this go away from Go's idioms?
Like what?
Like,
I mean, yes, but elaborate.
Well, Go is pass by value, pass by type. And that's probably the reason why we don't use the reflection package too much or too often.
I mean, that's nice, isn't it? I mean, in dynamically typed languages, so-called, like Python or Ruby, you can get a parameter and you have no idea what it is.
Right.
You don't know whether you can do string-like things with it, or whether you can do arithmetic with it, or whether you can access its fields or whatever. And those languages have ways of figuring that stuff out. But if you try to do something which is not appropriate for that type, it will just kind of cope, won't it? Like, it'll try to do something and keep on running. It doesn't tell you, it doesn't fail to compile, because they're not compiled languages. It doesn't crash with a runtime error. It just kind of YOLOs it, which that's great for some situations. Other situations, you're like, no, I don't want that to happen in production. I don't want you to just silently carry on if I've made a programming error. I want to know about it right away. Ideally, I won't even have deployed this code because the compiler caught it while it was being built. So, if you like that style of programming, which I think I'm coming around to after a few years, then you're saying, Mike, this doesn't really fit in with that because now you can have completely generic things.
Right.
Yeah, I agree. I think that's a fair point.
And my understanding should impact on the performance too, right? Untyped values are slower than typed.
That's a really good point. I don't honestly know the detailed answer to that. One thing I know about languages like C++, for example, is that they're supposed to provide zero cost abstractions. So where you have things where you're passing some type and you call a method on it, and the specific exact piece of code that ends up being called depends on the type. Like, here's the max function for strings, here's the max function for integers. That's just taken care of by indirecting into a table in the machine code, so that basically there's no runtime reflection. It's like, you know, it just has a lookup table of, oh, if it's an int, call this, if it's a string, call that. So I don't think that's what's being proposed in Go, but I'm not sure. But I think clearly if it's to be useful, it can't be massively slower than what we have now. And there is a bigger question, right, about if you introduce generics like this to satisfy the small but vocal minority of people who want it, mostly non-Go programmers, it has to be said, can you just bolt it on? Or do you have to rethink the way things like the standard library work? You know, think about all the things in the standard library which take specific types, but could in fact take generic types.
Not that this is about me, but I would just prefer they handle this with interfaces.
Yeah, well, perhaps, you know, if you, one thing I find about interfaces is when you first find out about them and you think, who ordered that? I don't like it, don't want it, don't need it. And after a while you come across something and you think, I actually do need interfaces now. Nonetheless, you learn to keep them to a minimum just because they make things such a pain, as we've been saying.
That's what I see here. I don't think I can find one real world reason for me, at least, to use generics, which means I'd be keeping them to a very minimum, which was what I would do with interfaces anyway. So why not bake this into that?
Yeah, I agree with that. But the point is, if the powers that be decide that that's what they're going to do, there is some thinking to be done about whether to try and, because it'd be a little puzzling for new gophers, right? They come to Go and they say, okay, I see we have generics, but this thing in the standard library doesn't use them. So why can't I call a generic, you know, why can't I call sort.slice, for example, with some generic type? And that would be a valid question or objection, because now you have two basic ways of doing things in Go. One is the generic way and one is the traditional way, if you like, using interfaces or concrete types. And there'd be no real rule to know when it's one or the other. It's just historical reasons, which would make the language objectively worse, I think. Or the alternative to that is basically you refit everything with generics. Right, you backport it to all the standard library. You break all of the code out there in the world that exists. That's probably going to happen anyway, which is why this is called Go2 so-and-so, and you'll see the program name has an extension of Go2, just to make it clear.
So we're going to be like Java and Python.
Yeah, I really hope not. So I think there's some further thought to be done there about how, you know, I don't like either the alternative of rebuilding everything to be generic, especially because most people will probably not need it, or alternatively just making it a special red-headed stepchild that only works for certain things. So I don't know what the answer is there, but from the point of view of syntax, I thought it's interesting to look at what's proposed, you know, and of course nobody would be happy with everything, and you'll never get everybody happy with any one specific point. Everybody would like different types of brackets here, for example. And what seems obvious to one person because they're used to C++ is completely confusing to someone else. One last thing I wanted to mention is, suppose we want to constrain our type in some way which isn't about being comparable, and it also isn't a method set. So a max function is the classic example of a generic function. So let's try this. And it's one of the complaints I see about Go. You know, people try out Go, and the first thing they do is like, okay, let's make a slice of integers and let's make a function which returns the maximum one. And the first thing they say is, why isn't this in the standard library? Because it's so obvious, right? It's, you know, I can't believe they missed that out. Like, did they just not think of it? Did they not realize people want to find the maximum of a slice? And that's not how it works at all. The Go syntax, the Go language and libraries is not about what could we reasonably put in. It's what could we not reasonably leave out. That's a very different way of thinking about it, isn't it? Just saying we want this to be easy to learn for people, so the less stuff there is in it, the quicker people can learn it. So we want to take out absolutely everything that we can and still leave a language that you can actually write useful programs in. And I think they've got the balance just about right. Not everybody agrees. But it's very trivial to write your own max function. It's just this. So that's one argument for not providing it. But suppose we would like to write this generically. So let's try and get the max of a slice of int, because it's easy. So does this work? No. Why doesn't it work? Because we've said any t, and we're using the greater than operator. And again, the compiler has no guarantee that for any t that will be appropriate. It's not appropriate for structs, for example. So we need a way to express the fact that, in fact, that you can use the greater than or less than operators. And the technical term for that is ordered. So how can we tell the compiler that our type is ordered? One thing you can do is there's a thing called a type list, which, remember, we could specify an interface as the constraint, like stringer. And there's actually another type of constraint we can use, which is, rather than to say anything about the method set that the type has, just list all the types. You know, just literally say them all. Float 64, float 32. No one's ever used float 32 for anything, but you'd have to list it. Int 8, int 16, int 32, int 64, int 8, and so on. And that's, I can't even be bothered to read them out, so you wouldn't feel like typing them, would you? And what if you missed some out? You know, that would be a nightmare. So the proposed list, they're going to provide a new standard library package called constraints, which will have things like this in it. So you'll just be able to say constraints.ordered. And I don't think we actually have that. I don't think this is simulated yet in the playground. No. No, I can't import it, I don't think. But as I understand it, that's the proposal. This stuff is fun. Look into the playground if you're not familiar with it, because there's some really interesting things about it. The generics playground even more so. But that's the idea, that you're going to be able to say constraints.ordered. And we already looked at generic types, because that's what we started with, isn't it? Type record of t any is a struct with a field of t any. And that's basically it. So there are more issues about generics and more things that you might want to do and more complicated things like functions that take functions and all of this. But if you're struggling to think, when would I ever use even the basic ones, like me, then perhaps you don't need to go into those. So maybe we'll take a couple more questions if anybody has any. Change this because it doesn't work. Or have we basically heard enough and we remain unconvinced?
I don't yet know enough to say whether or not I feel like I know that generics are useful. I know that there are other styles of programming that in which they're incredibly useful. How I use them or how Go might implement them, I just don't know as of yet.
Yeah, so could you give an example maybe of the type of thing where it would be super useful?
It's
putting you on the spot rather, but
yeah, I mean, this is.
I've always struggled to think of any myself. But, and the
I
one
mean, I think
back is people say, well, I want to write a generic container library, whatever. Yeah, but supposing you didn't want to do that, what specific use case would you be writing that for? I've never really had a good answer.
That's a you are putting me on the spot because the only example I have is that style of example, right? I want to make something that is globally useful.
Yeah,
and I want to provide some generic, implementation of some kind of functionality that's useful across the place. Now, I'm not a person that's used generics a lot in other languages, so I can't speak any better than that.
Yeah, I mean, I think that's fair enough. The fact that we can't think of any good examples offhand, it kind of means the point is made, doesn't it? And some people might perfectly well say, well, I just want to write the generic library because I want to write it and it's fun. There's, that's legit. I don't have a problem with that. But if you're saying Go's lack of generics means there's some specific industrial or commercial application which I can't write using Go, and so therefore I've chosen Java or insert any language you like. I'm yet to hear a really convincing use case of that. And I suspect because most of the pressure for generics is coming from people who don't know Go, but they've looked at it and said, oh, no generics, no deal. They're used to solving problems that way in their favorite language, and they don't realize there's actually alternative ways of doing it in Go, like interfaces and things, as we've talked about. And in some ways, I much prefer being able to use interfaces. Because it's.
I mean, the one thing I can say is that the implementation of generics versus type assertion, I think, has some merit to it in that you can catch what's going on, I think, maybe easier. Like the shenanigans with the underlying data types. Like what, I'm expecting I could get anything here. I'm going to try to handle that. I might be able to catch that a little bit easier with generics. Again, based on the surface of this discussion versus what I've seen with type assertions where I have to handle, hey, I'm going to try to assert that this thing is this type, but I'm going to have to also handle if it's not.
Yeah.
Right, at runtime.
That's right. Yeah, I agree with that. I think what you're really saying is if you probably don't have to write much generic code in Go, but if you do, it's a lot easier to do it this way than having to assert stuff about empty interface all the time. Or if you've written code that works with map of string to empty interface, like if you're dealing with arbitrary JSON data that you don't know the schema of, or Terraform data, I can confirm that this is a royal pain. So it would be significantly easier to do this. So yeah, I think I could sum up my feelings about it by saying I don't think it's necessary, but if it must come, please let it be as simple and minimal and Go-like as possible. Right? Don't just bolt on something horrible. And I don't think they will. So we'll see what happens. But I'm afraid we're out of time. It's been a fun discussion. Thanks very much to everybody for being here.
Thank you. Have a great day.
I really enjoyed it, and see you again next time.
Yes. Thanks, John.